In the annals of military history, there exists a specific category of artifact, the desperation weapon. These are devices born not from standard military doctrine, but from the terrifying urgency of total war. They are often ingenious, frequently bizarre, and almost always fatal, sometimes to the enemy, but often to the user. Hidden within the archives of the British Special Operations Executive is perhaps the most perfect example of this phenomenon. To the untrained eye, it appears to be a piece of industrial plumbing, or perhaps a machinist's tool. It is a simple cylinder of dark steel, 7 inches long, innocuous, and heavy. But this object, known as the McLaglen pesket, is a declassified testament to a specific moment in history when Britain was willing to try anything to survive. It is a secret weapon designed for a singular, grim purpose: the silent liquidation of human targets. It is a mechanical assassin, a World War II mystery that combines 3 separate methods of killing into one wrist-mounted device. And yet, for all its complexity and the brilliant craftsmanship behind it, it stands today as an engineering disaster. This is not just the story of a weapon. This is a case study on the limits of ingenuity, the physics of violence, and why, in the brutal calculus of war, simplicity usually defeats complexity. Part 1. The Strategic Context, 1941. To understand the engineering decisions behind this device, we must first understand the environment that demanded it. The year is 1941. The geopolitical map is a nightmare for the Allied forces. The Wehrmacht has overrun France in 6 weeks. The Low Countries are occupied. The Balkans have collapsed. Britain stands isolated, an island fortress under siege. Winston Churchill, recognizing that a conventional invasion of Europe is impossible, authorizes the creation of a new entity, the Special Operations Executive, or SOE. Their mandate is famously brief: set Europe ablaze. This meant a shift from conventional warfare to asymmetrical sabotage. The goal was to infiltrate occupied Europe, destroy infrastructure, and bleed the German war machine from 1,000 cuts. However, sabotage requires proximity. To blow up a railway bridge or cut a communication line, an agent must physically reach the target. Standing between the agent and the target were the sentries of the Third Reich. Thousands of guards protecting radar stations, ammunition dumps, and command posts. The tactical problem facing the SOE was one of acoustics and timing. A gunshot, even from a suppressed firearm, creates a mechanical noise that travels. A hand-to-hand struggle is unpredictable. A sentry might shout, fire a wild shot, or simply hold on long enough for a patrol to arrive. The requirement, therefore, was for a method of elimination that was instant, silent, and mechanically reliable. The SOE needed a weapon that could transition from concealed to lethal in a fraction of a second. Part 2. The collaboration of OPP. Solution to this tactical problem emerged from a partnership that encapsulates the chaotic creativity of wartime Britain. It was a collision between high-end industrial craftsmanship and theoretical martial arts. On the manufacturing side sat John Edward Pesket. In 1938, Pesket had become the managing director of Cogswell and Harrison. Established in 1770, this firm was not a mass production factory. They were artisans. They built bespoke shotguns for the aristocracy and possessed a level of precision, machining capability that was rare in a wartime economy strained to its breaking point. Pesket brought the engineering rigor. His partner, however, was a man of a very different cloth. Sidney Temple Leopold McLaglen. Born in 1884, McLaglen was the brother of Victor McLaglen, the Oscar-winning Hollywood actor known for playing tough guys in John Ford westerns. While Victor played soldiers on screen, Sidney attempted to embody them in life. He styled himself a world champion of jiu-jitsu. He authored manuals on close-quarters combat and bayonet techniques. Historians have often viewed McLaglen with skepticism, man who perhaps blurred the lines between his actual credentials and his aspirations. Yet, in the desperation of 1941, the British military gave him a commission in the Royal Naval Volunteer Reserve. They didn't care about his resume. They cared about his ideas. Together, they filed British patent GB 559747A. The abstract describes improvements in or relating to close combat weapons. It was a clinical description for a device that was, in essence, a wrist-mounted slaughterhouse. Part 3. Anatomy of the Diavist Silitus analyzed the McLaglen-Pescott not as a curiosity, but as an engineering project. The device is a cylindrical assembly, approximately 7 inches long and weighing between 500 and 600 grams. It was finished in parkerized steel chemical phosphate conversion coating used to increase resistance to wear and, crucially, to reduce light reflection during night operations. The user would strap this cylinder to their forearm, using a heavy webbed strap, concealing it beneath a jacket sleeve or a mechanic's coat. Inside this single tube, McLaglen and Pescott attempted to integrate 3 distinct weapon systems. First, the rotational bludgeon, or Cosh. At the top of the cylinder sat a heavy spherical ball, roughly 1.3 inches in diameter, cast from lead and steel. This ball was mounted on a rotating swivel. The operational theory was based on the concept of the blackjack. By whipping the forearm downward, the heavy ball would strike the cranium of the target. The designers believed the mass of the ball, combined with the rigidity of the metal housing, would deliver sufficient kinetic energy to fracture a skull or induce immediate unconsciousness. Second, the retractable garrote. The ball served a secondary function. It acted as the winding mechanism for the internal spool. Inside the housing was a drum wrapped with 24 inches of high-tensile piano wire. Piano wire was selected for its high carbon content and lack of elasticity. Unlike rope, which stretches, steel wire bites immediately into soft tissue. To deploy, the operative would pull a ring grip, unspooling the wire. The tactical doctrine involved looping this wire over a sentry's head from behind, crossing the wrists, and using the mechanical strength of the wire to crush the larynx and windpipe. Third, the gravity stiletto. The final component was concealed within the hollow body of the tube. A 5.5-inch stiletto blader needlepoint thrusting weapon, designed for penetration rather than cutting. The deployment mechanism was arguably the most complex part of the device. It featured a spring-loaded button on the side of the casing. When depressed, it released a lateral locking arm. The user would then flick their wrist downward, and gravity would slide the blade out until it locked into the open position with an audible click. This gravity knife concept was intended to allow deployment even if the operator's hands were wet, cold, or injured. Part 4. The engineering of fail-tree on the blueprint. The McLaglen-Pescott appears to be a triumph of miniaturization. It fits 3 lethal tools into the space of a flashlight. However, when subjected to the harsh physics of reality, the design begins to crumble. This device serves as a textbook example of mechanical overconstraint, trying to make one tool do too many things, resulting in a device that does none of them well. Let us examine the bludgeon component. A traditional police baton or trench club functions on the principle of leverage. The weapon acts as a lever arm, multiplying the velocity generated by the wrist and elbow. The McLaglen-Pescott, however, is strapped directly to the forearm. This eliminates the wrist's range of motion from the kinetic equation. To generate enough force to incapacitate a man with a 1.3-inch ball strapped to your wrist, you cannot simply flick your arm. You must swing your entire limb like a pendulum. This requires a large telegraphing motion, the exact opposite of the subtle, compact movements required in covert elimination. Furthermore, 600 grams is heavy enough to be fatiguing to wear, but arguably too light to guarantee a one-hit knockout without the leverage of a handle. Then there is the fragility of the garrote mechanism. In the prototype phase, one example of which surfaced from the Wilkinson Sword Toolroom archives, the internal spool was too small. When stiff piano wire is wound tightly around a small diameter, it develops stress fractures. Imagine the scenario. An agent sneaks up behind a guard, deploys the wire, and applies maximum tension. If that wire snaps due to metal fatigue, the agent is left standing inches from an alert enemy, holding a broken piece of string. It was a catastrophic failure point built into the design. Finally, the unreliability of gravity. Gravity is a constant force, but friction is a variable one. In a clean workshop, the blade slides perfectly. But in the field, mud, grit, congealed blood, or rust can easily foul the internal track. If the blade slides only halfway out, it fails to lock. A non-locked blade is useless. Worse, if the agent is in a grapple on the ground and their arm is not pointing downward, the blade cannot deploy at all. Compare this to the standard issue Verbandsykes fighting knife. The FS knife has no moving parts. It cannot jam. It cannot run out of battery. It cannot fail to deploy. It is a sharpened bar of steel. In the life or death struggle of close combat, reliability is the only metric that matters. The McLachlan Pescott was simply too clever for its own good. Part V. The legal and psychological risk beyond the mechanical failings. There was a darker, more cerebral reason why this weapon was rejected by operatives in the field. It concerns the psychology of the spy and the legal operational framework of World War II. Operatives working behind enemy lines relied on cover. If captured, they needed a story. Even if they were caught in uniform, they hoped to be treated as prisoners of war under the Geneva Convention. However, in October 1942, Adolf Hitler issued the Kommandobefehl, or Commando order. This directive stated that any Allied commandos found in Europe were to be executed immediately without trial, regardless of whether they were in uniform. While the danger was already high, the equipment an agent carried could seal their fate. A Verbandsykes knife could be explained away as a soldier's survival tool. It was standard issue. The McLachlan Pescott, however, stripped away all plausible deniability. It was not a tool for opening rations or cutting rope. It was an assassination machine. It had no civilian application and no defensive military function. To be caught with this device strapped to your wrist was to admit, undeniably, that you were a saboteur and an assassin. It would not only guarantee execution, but would likely invite the most horrific interrogation techniques the Gestapo could devise. Experienced SOE agents were pragmatic. They refused to carry a weapon that acted as a signed death warrant. Part VI Legacy and RAIT Wythe. The operational history of the McLachlan Pescott is defined by its absence. We have scoured the mission logs of the SOE and the OSS. We have read the memoirs of the men who served in the Jedburgh teams and the Devil's Brigade. There is no confirmed record of this weapon ever taking a life in combat. Robert G. Siegel, a noted small arms historian, delivered the blunt assessment: there is no evidence that these were ever used in actual operations. They appear to be more a souvenir than an actual field service item. Production numbers remained pitifully low. Most experts estimate that only about 24 were ever manufactured. By 1944, the SOE had standardized their equipment. The Welrod pistol for silence, the Verbandsykes for close work, and the Sten gun for firefights. The all-in-one concept was abandoned. Ironically, the weapon's total failure as a military tool has made it a holy grail for collectors today. Because so few were made, and because so few survived the scrapping drives of the post-war era, a genuine McLachlan Pescott commands extraordinary prices. In 2022, a prototype sold for nearly $1,000, while production models can fetch upwards of $7,500. CO1C, USEO under McLachlan Pescott serves as a powerful reminder of the road not taken in military technology. It represents a moment when British engineers, faced with the terrifying prospect of national annihilation, explored every conceivable method of defense. It is a monument to creative desperation. It reminds us that innovation is a process of trial and error. For every legendary success, like the Spitfire or the radar network, there were hundreds of failures like the McLachlan Pescott ideas that looked brilliant on a blueprint, but failed in the mud. It remains a 7-inch tube of dark steel, concealing 3 ways to kill, which ultimately proved that the deadliest weapon in war is not a gadget, but a determined human being with a simple tool.